Hi everyone, welcome to the new module Operators Part 2. In this module, we will talk about the mixed operations, and we will also continue with the remaining operators that we have left, and we will talk about the unary operators as well as the assignment operators of Java. So first, let's start it with the mixed operations. What is a mixed operation? Well, the definition of mixed operation means whenever you have multiple operators and operands of different types are involved in an expression, it's known as the mixed operations. Okay? So if the multiple operands and data types are same, if the multiple data types are same in the expression, then it's not a mixed operation. But for example, if you have like int, double, they are mixed together with multiple operators, then it's known as the mixed operation. Okay. And if you look at the third one here we have int x, int y, and int z. All of them are same types, but we also have different operators. One is plus, the other one is multiplication. So multiple operators and operands of different types, if they are being involved, that means it is mixed operation. Okay. And when it comes to mixed operation, there are a couple rules in Java that you need to be aware of. The first rule is when an operation involves two different data types, except for byte and short. Byte and short by default they are converted to int. As long as the operation involves two different data types other than byte and short, then the smaller one is casted implicitly to the larger one. For example, here you see, if I have int x minus long y. So here we do have mixed operation. We have this smaller, we have this int type and we also have this long type, right? If we subtract long from the int, then this smaller type int, it is casted to the larger type, which is long. So therefore the return type will be long in that case. And if you have this long x, that is long variable x multiplied by float variable y. So in terms of range of value, float is larger than long. So therefore, the result will be float at the end, because this long is casted to the float in the calculation. So the return type will be, returning value will be float from here. And if you have float divided by double, then return value will at the end will be double, because float will be implicitly casted to the double type. Okay. And as for the byte and the short are implicitly casted to the int before the arithmetic operation. For example, if you have byte plus byte variable plus byte variable, both of them will be implicitly casted to int, and therefore your return value will be int at the end. Okay. And if you have byte minus short, byte and short, those two variables are also implicitly casted to int, so that at the end the return value will be int. Okay. So byte and short you have to be familiar with when it comes to mixed operations, because byte and short both are casted to the int whenever you use them with the arithmetic operations. Now let's do a couple more examples with the mixed operations in our IntelliJ. Please open your IntelliJ, and under the source folder, please create a new package, name it module 12 operators part 2. And please create a new class and name this new class mixed operations. Okay. I'm going to give you a couple more examples of the mixed operations in this class. This example is to recap the rules of mixed operations. Suppose that here we have this byte variable which is num1, and let me initialize 100 to it. And then we have a short variable num2 which is set to, which we assign a 20 to it. Okay, num1 is 100, num2 is 20. Now, what happens if I calculate the addition of num1 plus num2? Num1 plus num2. So the result should be 120, right? If it is 120, does that mean that I can store this expression into the short variable? Let's see what happens if I try to store it into the short variable num3. See, it is giving me compile error, okay? The reason it's giving you compile error is because right now there is a mixed operation. This one is byte, this one's data type is byte, and this one is short, okay? And based on the rules of the mixed operations, whenever you have byte and short, they are implicitly casted to the int, right? But if they are not byte and short, if they are two other different type of data types, then smaller one would be casted to the larger one. But here we are using byte and the short. So this byte and short, they are implicitly casted to the int. So this addition, it will return me an int data type. If it returns you int, you cannot directly assign int to this short variable. Therefore, it's going to give you compiler. You see, when I move the mouse over to this line, it's also telling me that num1 plus num2, it is returning me int. IntelliJ is smart enough to tell you what kind of value the mixed operation will return you. So if it is returning you int, you cannot directly assign it to this variable. You may cast the final value to this variable. If I need to correct this line, let's see what's the suggested solution of this IntelliJ. It says cast the expression to short. So this is our expression, you see, num1 plus num2. Those two, this num1 plus num2, they are placed in the parentheses because this is an expression. Expression needs to be evaluated first before we cast it. Okay? So num1 plus num2 will be calculated first, and then the integer result, which has the default data type of int, will be casted to the short, and then you may store it into this short variable. Okay? So here we do have this mixed operation. That's why we had to cast it in order to be able to store it into the short variable. The calculation result of this is going to be int. Int now is casted to the short, and then we stored it into this variable. So whenever you have larger type that is casted to the smaller type, then it's known as what? Which type of primitive type casting it is? When the larger primitive type is casted to the smaller primitive type. It's known as the explicit casting. Okay? So this one this one right here is explicitly casted to the short, and then we stored it into this short variable. And now let me give the mixed operation example with different data types. Suppose that here we have int a, which is equal to 100, and then we have this long b, which is equal to 200. Okay? And I want to get the sum of those two numbers, a plus b. So based on the mixed operation rules, when you have two different operands, smaller one is implicitly casted to the larger one. So this is the smaller type, right? Smaller type, int, now is implicitly casted to the larger type, which is long. So therefore, the return value here is going to be long. If the return value is long, if you try to store it into an int, you see, you would still get compilator. So therefore, here I have to give long. Okay? And what if I have this one? Short x is equal to 2. And here I have another variable with the data type of float, which is equal to 2.5. And in order to make sure that this number will be taken as a double, in order to make sure that this number will be taken as a float value, I need to add lowercase or uppercase f. Otherwise, it will be taken as double. Okay? And if I multiply this x to y, short multiplied to float, short primitive variable is multiplied to the float primitive type of variable, then your final result is going to be float, right? Because smaller one will be casted to the larger one implicitly. So therefore, it's going to return me float, and I can store it into the float variable of z. Okay. And let me print this variable z. Let's see what the value is. The value of the z is 5.0. And now I hope it will make sense to you why when we divided those integer numbers by the doubles, we ended up getting double result. Okay, because because it's also known as the mixed operation. Based on the mixed operations rule, smaller one is implicitly casted to the larger one, so it will become double multiplied by double. But of course, if you did not give the but of course, if you did not give any different data types for the new denominator, for example, if it was 9 divided by 3, this one is not a mixed operation now, okay? Because they both have the same type, the numerator and denominator. Then you ended up getting the same type, which is int. Thank you so much, everyone. See you all in the next video.